All right, so obviously we're talking about binomial expansion, right? And what does that mean? That means, we said if we had x plus 3 squared, well, how do we do that? And I really was focusing on yesterday, I tried to drive home the point of we do not want to ever distribute a power through or past a plus or a minus, right? I said that a bunch of times yesterday. So if it's just squared, it's not a big deal, right? And even if I did it cubed, well, what does that mean? Well, I'm going to do it and multiply it times itself 3 times, right? And that wouldn't be terrible, that would be doable, but it's still very tedious. But if we wanted to do 4th or 5th or 7th power, that would take a really long time, right? And if I were taking an ACT test, time is very valuable, so I don't want to waste any time. So there is a different method to be able to do this, okay? And it's called binomial expansion. So again, obviously it only works on a binomial. And we can use Pascal's triangle. So Pascal's triangle, you've probably seen it before. So it starts out like that. And then we fill in the number, and every time I'm between a number, I take the sum of the two that I'm between. So it's always going to have ones on the outside. Well, since I'm between these two numbers right here, what's 1 and 1? 2. And then I can create my next row and put my ones on the outside, but now I'm between 1 and 2, so that sum is 3. This sum is 3. And then my ones are always on the ends. You see how it's building? So what's my next one? 1 and 1. What's here? And we could go on forever, right? But you get that. So what this does is, these are the numbers that we're going to use, and I'm going to show you how to use them. So I'm going to use A and B first, in general. And I want to show you how it develops. So, this is the one that we're going to use for a power of 1. This is going to be the one we use for a power of 2, a power of 3, a power of 4, and so forth. Okay? And those numbers are our coefficients that we're going to use. So I teach this in a very loose way, I guess, and it's not using very mathematical terms. But these are our 2 terms of our binomial, right? So we're going to write those down, A, B. And we need, for whatever power, we need this many of them to write. So since we're using the first power, we're just going to use that 1, okay? And we know anything to the first power is itself, correct? So, actually I lied, we need 2 of them, A, B, A, B. So, because we need 1 for each one of these. So if we're doing second power, we need to write 3 of them down. So this would be in front of each one of these things. So since we're using the first power, we're going to use this row, and these are the coefficients that go in front of each one of these things. Now this is very extra for the first power because we already know that anything to the first power is itself, right? So we know the answer here is A plus B. I'm just showing you how this develops. Now, we're going to use the exponent and go in reverse order. So we're going to go from that exponent down to 0 and then in opposite order. So we start with the A's, the first term. Start with the exponent and go to 0. So that one's very simple. You'll see more what I'm talking about as we get with bigger and bigger numbers. And then with the second term of the binomial, we're going to go in reverse order. So we're going to start with a 0 and go up to whatever that exponent is, and this is going to be plus here. What is something to the 0 power? You guys know that? So anything to the 0 power is 1. So if I have, I don't care what the value is, that's 1.
This is not multiplying by anything.
Say again?
Not multiplying by anything.
We're not multiplying it times anything, because multiplying times 1 is not changing anything, right? So essentially, what do we have here? A to the first power is just A, times 1 is what? Just A. And then B to the first power is B, times 1 just gives us this A plus B. And I know that was a ton of work that was very unnecessary to raise something to the first power. But when we do this next one and then the third one, you'll understand why we started there to show the development of how this all works. So now let's look at A plus B squared. So we're going to use this term. So if I have 3 coefficients, I want to write A and B down 3 times. Everybody with me? And we're going to use Pascal's triangle to tell us the coefficients of the numbers that go in front. So which ones are we going to use? 1, 2, and 1. You see it? Now, this is where you'll start to understand a little bit better how we're going to use the exponents. I'm using an exponent of 2. So remember, for the first term, which is A in our case, we want to start with that and go all the way through down to 0. So we're going to go 2, 1, 0. And then what would we do to the second term, or our B term in this case? We go backwards. We start with 0, 1, and 2. So now if we clean this up, what's 1 times A squared times 1? Just A squared. What's 2 times A times B? 2AB. And then what's 1 times B squared? So if we actually took the time to multiply this out, and I'll do it very quickly, outer, inner, last, how many ABs do we have? 2 of them. So it gives us the exact same answer. Now again, is this something that's practical to do, or is it just as easy or easier to do this? Of course, it's probably just as easy, if not easier, to do this, right? But now, if we're getting to a much higher exponent, then it's probably in our best interest to use the binomial extension. I'm going to scoot over a little bit, and I'm going to use A plus B cubed. So if we want to use the third power, we're going to use this third row. We don't count this first row at all. So that third row right there, now we're dealing with 1, 3, 3, and 1, right? As our coefficients. So we're going to write an AB for each one of those. So if I'm starting with the power and going down all the way to 0, doesn't it make sense that there should always be one more term than the power? So if you notice, I have a power of 1. Well, we had to write AB twice. I had a power of 2. I had to write AB 3 times. I had a power of 3. Now I'm having to write AB 4 times, because we're going to start at that exponent and go all the way down to 0, so that 0 adds one more term. With me? So now, some of you guys already started. What is the power that I start with A. 3, and then I go 2, 1, 0. And then what do I do with the B's? I start with 0 and go in the opposite direction. 1, 2, 3. So if we clean this up, what is 1 times a to the third power times 1? A to the third power. What is 3 times a squared times b? 3a squared b. And then this one is 3ab squared. And then the last term is b to the third power, b cubed. So do you see now kind of the development of this? And I know, excuse me, it didn't make a whole lot of sense looking at it right there, right? It was kind of like, you know, why are we doing this when it's just itself? But I wanted to show you how this builds and we get to each one so we can see that no matter what our power is, we can do this for every binomial, even though it may be kind of unnecessary here. So I want to try it with an actual number now. Let's do x plus 2 first. To the third power. So try to do this one. And I want you to keep the exact same setup we just did. What is going to be our A in this case? X. What's going to be our B? The 3. Oh, the 2, excuse me. So, you know, A was representing our first term no matter what it is, and B was representing our all right, so we're looking at expanding this, right? And we said our A was X and our B was positive 2. So since we're using the third power, we have to use this third row here. So we're going to write 1, 3, 3, and 1 again, right? From Pascal's triangle. And then we're going to write X and 2. And it looks kind of weird at first before we add the exponents. And again, we're going to have 4 of these because it needs to be one more than that to account for that 0 term, right? And one thing I didn't address before was this plus. All right, there was a positive term, so we didn't necessarily have to worry too much about, you know, it was always plus, and we'll look at it in a minute what happens if that's negative, okay? So we started with 3. 2, 1, 0. Now you may be able to do them both at the same time. For me, it's easier just to go 3 down to 0 and then 0 to 1. I don't have to think as hard. But you guys are smarter than me. See, I screwed it up. 2, 3, right? So now the only difference is instead of an A, we have an X. Instead of a B, we have an actual number that we can square and raise the powers. So let's look at how that changes this. 1 times 1 times x to the third power is x to the third power. Plus 3 times x squared times 2. How can I simplify that down to one thing?
3x squared times 2.
So what's 3 times 2 though?
6x squared times
6, there we go. We can multiply those things together. So if we leave the 3 and the 2 separate, we haven't combined that all the way. We can always multiply 2 regular numbers together, right? All right, plus? What is 3 times x? What's x, or it's 2 squared, excuse me. What's 2 squared? 4, right? So what's 4 times 3? So that term right there is just 12x. And then the last term. 1 times 1 times 2 to the third power, which is what? 8. Did we get that? So if you made a mistake, you see where you made a mistake. And I saw a couple of people just didn't multiply those numbers together. But that's an easy fix, right? We can always know that we can multiply them. But as long as we had it set up, we should be able to correct those mistakes pretty easily. All right, so let's take a look at what happens if that term is negative. We'll just leave it to the third power for now, and we'll try one more after that. So try that one. All right, so we're still doing third power. So we're going to write this down 4 times. So the way I would probably write this down is I would go ahead and write my coefficients. And then I would say x. And at first, to me it's easier to go ahead and write that as a -3 in parentheses. All right, we were able to write that 3 before, or the 2 we did, or the b. Just put it next to the x because it was a positive number. Now this negative changes some things. And we can go ahead and write the plus -3 plus x, -3 plus x. Oh, I didn't even put the x in the parentheses. X in parentheses, -3. Now that plus is there just to visually show us that there's a separation. These are different terms, right? It's not just a bunch of numbers pushed together. All right, so now nothing's different because we have a negative. We're still going to do our exponents from 3, 2, 1, 0, and then from 0, 1, 2, and 3. So now, of course, these terms all go away except for the x cubed. Now this one we have to think a little bit. What's -3 to the first power? -3 times another 3. -9x squared. And I saw most of you had that down on your paper. Now the next one. -3 squared is what? +9, because why? Because the negative is part of what I'm raising to a power. Okay? That's totally different than if I had -3 squared like that. That's why I think the parentheses are important, especially at the beginning. So if the negative is part of what I'm multiplying, then we have a negative times a negative, which gives us positive. So +9 times +3 gives us what? +27, and then x to the first power. So I did see a couple mistakes there with the sign. Easy to fix. And then the last term, what's -3 cubed? -27, right? Because a negative times a negative is a positive. Then that positive times one more negative turns it back to a negative. So we have -27 times 1 times 1 gives us -27. Okay? So a couple things to think about. How can these problems change? Well, of course, our exponent can change. Can we still do this if there's a number in front of the x here? Like if it was 2x minus 3. Yeah. Our first term would just be 2x now. And it may be helpful to put it in a parentheses. Could we also do this if this was x squared minus 3? Is that still a binomial? Absolutely, right? It's 2 terms. Can we do that? Sure. just remember that now the a term would have a squared in it every time, and we'd be raising a power to a power. So how do I raise a power to another power? Does anybody know that exponent rule? So if we raise a power to a power, we have to multiply those two things together instead of add. You guys never seen that rule before? So anytime I'm raising a power to a power, I multiply those two things together. Okay? That's different than if we're multiplying the bases, that's when we would add those guys together. Right, you see the difference? So we got a couple on the homework or the classwork that you're gonna have to raise a power to a power because there's an exponent inside of what we're trying to expand. And then of course if there's a coefficient there, then all we have to do is just carry that along as part of our term. Alright? So we're gonna work on that, those 10 questions right now, and